A researcher conducted a study to investigate whether local car dealers tend to charge women more than men for the same car model. Using information from the county tax collector's records, the researcher randomly selected one man and one woman from among everyone who had purchased the same model of an identically equipped car from the same dealer. The process was repeated for a total of 8 randomly selected car models. The purchase prices and the differences woman-man are shown in the table below. Summary statistics are also shown. Dot plots of the data and the differences are shown below. Do the data provide convincing evidence that, on average, women pay more than men in the county for the same car model? To verify the claim that women pay more than men for the same car model, we have to begin setting up the proper null and alternate hypotheses, H0 and HA. Let mu-D denotes the mean of all the pair differences in purchase prices women-men in this county. The null hypothesis will be that women and men pay the same price for the same car model. The alternate hypothesis will be that women pay more than men for the same car model. A p-value alpha is not given for this problem, but usually it takes the values 0.1, 0.05 or 0.01. Because this is a paired difference of size n equals 8 coming from 2 random samples, and because these differences have an acceptable symmetric distribution respect the midpoint of the highest and lowest values in the corresponding dot plot, a t-test seems appropriate. Calculating then the corresponding t-test statistic, plugging in this formula the corresponding values for d bar, the average of the differences of prices paid by women and men, sigma the standard deviation of these differences, and the sample size, we find that this is approximately equals to 3.1178. We have now to determine the next probabilities. The probability to have a difference in price greater than $585, that is equivalent to find the probability to have a value for the t-statistic greater than 3.1178, or by the symmetry properties of the t-distribution, the probability to have a t less than negative 3.1178. Using a table or a calculator with degrees of freedom equals 7, this probability is going to be equals to 0.008448. Then, the probability to get an average pair difference of $595 or more is about 0.8448% only. Considering that this probability, 0.008448, is less than any of the usual levels of significance used for this kind of test, from 0.1 to 0.01, it's very unlikely to obtain a random pair difference with average $585, assuming that on average, women pay the same prices than men in the county for the same car models. We can conclude that this data supports the claim that women pay higher prices than men for the same car model.